This is Geometry B, Unit 7, Lesson 3. We're talking about something called inscribed angles. So first we need to define what an inscribed angle is. So we start with a circle. Draw a circle with a center and a point on the circle here. Okay. An inscribed angle is an angle that has a vertex or a corner on the circle. So if I place 3 points on this and draw an angle right here. In fact, I want a ray, not a line. So ray, there it is. Okay, I want a ray, so ray CE and ray CD. Okay, that's an inscribed angle. Okay. An inscribed angle is an angle whose vertex is on the circle. Okay, that is in opposition to a central angle. That's an angle whose vertex is on the center of the circle. Okay, I'm going to draw both the inscribed angle and the central angle. I'm going to use line segments actually here. I think it'll be simpler. So here's an inscribed angle, angle C. Here's a central angle, angle A. Okay, and what this lesson is dealing with is the relationship between these two things. Now you may recall we can measure the arc as the measure of the central angle. So the measure of angle A is also the measure of arc ED. Okay, measure of arc ED is double the is the measure of angle A. Okay, so let's go ahead and measure some angles. Measure angle A, boom, boom, and boom. That's 59.9. And measure angle C. Okay, and we get, what is it, 30. All right, let's go ahead and move those so you can see them a little better. Okay, now I'm going to play with these a little bit here, and we're going to hopefully notice a relationship. So I'm going to make this 60 degrees, if I can. There we go. Okay, and notice when the central angle is 60 degrees, the inscribed angle is 30 degrees. Okay, now let's make the angle 80 degrees. Okay, 80, oops, 80. There we go. And now when the central angle is 80 degrees, the inscribed angle is 40 degrees. Okay, let's make it 100. Okay, 100. Whoop, I had it. There we go, 150. What do you notice, I hope, right? You notice that the inscribed angle is always half the central angle, and that is the case. If an inscribed angle and a central angle intercept the same arc, the inscribed angle is half the intercepted arc, or the intercepted arc is double the inscribed angle. 100 is 2 times 50, or 50 is a half of 100. And that is always true. What's more is there's a little bit that falls out too. It doesn't matter where I draw the inscribed angle as long as it's on the circle. Notice moving point C, it stays 50 degrees no matter where I put it. Until, of course, I get past the intersection, right? But over here, anywhere on the circle, it remains half of the inscribed angle. And so that's another corollary as well, that any inscribed angle, as long as it intercepts the same arc, is going to be congruent. So if I draw an inscribed angle from B that intercepts the same arc DE, that angle B is going to have the same measure. Angle B is going to have the same measure, 50 degrees. Okay? And again, it doesn't matter the size of the triangle or where I put the point, they're always the same. Okay? Now that brings us to this point here. What about the case of a tangent? These sides of the angles are chords, and if I drew lines, they'd be secants. But tangents just touch once. So I'm going to draw a line. Actually, I'm going to draw a line CD here. Okay? And I'm going to examine what happens when D moves so that it becomes tangent, right? So when we get really close together, C and D are close together, okay? You may recall the angle between the radius and the tangent is 90 degrees. Does this relationship still hold? Is it still 1/2 the intercepted arc? 160.4, half of 160.4 is 80.2, and that's 99.8. Think about that here. Half of the intercepted arc. 93, 171, double 94.5, you get 186, 187. Oh, I see what's going on. This GeoGebra has gone to measuring the other side. Okay, so I need to set this up so that it's not obtuse. Okay, there we go. All right. So let's see. Let's make it tangent by putting the points really close together. 87.2 and 174.3. If I double 87.2, we get 174.4, and it's giving me a rounded answer here. If I change this to be a nice whole number, like let's say 160. 160. There we go. Now it's 80, right? And so it's true even of a tangent. Let me draw what this is talking about here a little bit. Okay. Okay. And hopefully I won't go too long here. So here's what we've discovered. We can draw a circle with a given center. Call it A. Okay. And I'm going to draw a circle with center A. Here's what we discover. If I have an arc between 2 points on the circle, an arc between 2 points on the circle, we'll call this B and C. And let's say arc BC measures 88 degrees. Okay? If I put any point anywhere else on the circle, just so it's not on the arc BC, call it D, then that angle, that inscribed angle, is going to be half the intercepted arc. Okay? So this angle right here, it doesn't have to go through A, it doesn't matter where on the circle it is going to be half the intercepted arc. So that means the inscribed angle is going to be half of 88, or 44 degrees. Okay, that's what we learned. We also learned this. We also learned that if you have a tangent, okay, a tangent and a chord. So we're going to draw a tangent here. A tangent is a line that just touches the circle once. Tangent. And a chord at that point of tangency. Chord at that point of tangency. Let's say it's like this. Okay. All right. And if this intercepted arc right here, measures, say 170 degrees, then this angle measures half of that. Half of 170 is 85 degrees. So that's what we learned, right? So a tangent and a chord are half the intercepted arc of the tangent and the chord, and an inscribed angle is half the intercepted arc for if they intersect the same arc. All right? Hopefully that helps.